For the next problem, we'll work part B of problem 9 in chapter 4. Calculate the pH of a 0.3 molar solution of sodium leucinate. Okay, so what is sodium leucinate? It's important to identify what we're working with before we try to work this problem so we can see what is affecting the pH. Okay, so we've got sodium leucinate, looks like this. So this is named as the salt of a carboxylic acid, sodium leucinate. So that's where the sodium is. And if you don't know, you can look that up. Okay, so if we don't have the carboxylic acid protonated, then we can also assume that the amine is not protonated because that pKa would preclude the amine being protonated before the carboxylic acid is protonated. So we're not going to have NH3 plus and then O minus here. Okay, so we can assume that this is the species that we're working with. Okay, and if we react that with water, then we're going to get what? We're going to get this. So we're going to increase the pH because this is already deprotonated and the amine group can pick up a hydrogen and become protonated. So what we're doing is increasing the hydroxide ion concentration. Okay, so we're increasing the basicity, so we need to deal with this like an pKb problem. Okay, so we can say that let's go ahead and set up our ice table here. So let's call this guy LEU minus 1. Okay, so the concentration of LEU minus 1 plus H2O, and that's going to be a liquid. I don't need to write that there. That's going to be a liquid. Okay, and that's going to give us LEU 0. This is our neutral species here. And then plus OH minus. Okay, that's our ice table. Okay, so initial change equilibrium. Okay, so we've got 0.3 molar is what we put in, and we start with 0 of this, 0 of this. So when we put this LEU minus 1 in water, it's going to react with water to give us more hydroxide and LEU 0. So we're losing X and we're gaining X of the LEU 0 and of the OH minus. Okay, and then we're going to have 0.3 minus X for at equilibrium for what we've lost of the LEU minus 1, and we're going to have X and X representing our other two species, our products, and notice that X represents our hydroxide ion concentration. So we could set up a Kb expression where Kb is equal to X squared over 0.3 minus X, because we've got products over reactants. Okay, or you could have written, remember, Kb is equal to products LEU 0. We'll just go ahead and write that in so you don't get confused, times OH minus over LEU minus 1. Okay, so Kb is equal to this when we plug that in. Okay, and also remember that Kw is equal to Kb times Ka. Okay, and that's equal to 1 times 10 to the minus 14. Now we don't know the Kb, we probably can't look that up, but we can calculate the Ka from the pKa. So the Ka is equal to 10 to the minus pKa, we have that formula, is equal to 10 to the minus 9.6 is equal to 2.51 times 10 to the minus 10. Okay, and Ka times Kb equals Kw, so Kb is equal to Kw over Ka. which is equal to 1 times 10 to the minus 14th, over 2.51 times 10 to the minus 10, which is equal to 3.98 times 10 to the minus 5th. So that's our KB. Okay, so now we can use this right here to calculate our x. Okay, so remember what we just said, KB is equal to x squared from our ICE table over 0.3 minus x. Okay, so if we assume that x is small, then x squared is equal to KB, so we're assuming x is small here, KB times 0.3, okay, so x is equal to the square root of KB, which is 3.98 times 10 to the minus 5th, times 0.3, which is 3.46 times 10 to the minus 3rd. And that is our hydroxide ion concentration. Remember, X was also equal to our hydroxide ion concentration. All right, so now we know what our hydroxide ion concentration is, but that's not going to give us the pH, that's going to give us the pOH, okay? So pOH is equal to the negative log of the hydroxide ion concentration, which is the negative log of 3.46 times 10 to the minus 3rd, which is equal to 2.46, okay? And pH is equal to, pH plus pOH is equal to pKW. So pH is equal to pKW. I'm doing this. pKW minus pOH, which is equal to 14. pKW is 14 minus 2.46, which is equal to 11.53. So we have our pH, which is 11.53, which is basic, which is why we had to use the pKb instead of the pKa to do this calculation. If you use pKa, you'll be able to set that up, but you'll get the wrong answer. You'll get, you'll get the wrong answer. You'll get an acidic number. Thanks for watching. In the next video, we will do part C.